Welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. So this is the very important and interesting paper, that is electronics and experimental methods in CSIR and GATE also. Electronics and experimental methods very important. In GATE there is no experimental techniques, but in electronics they added experimental methods also. They are giving from experimental method 3.5 marks question in every CSIR examination. So it is very easy. If you know electronics is very easy compared to all the subjects. If you want to learn the electromagnetic theory, you know the mathematical background, spherical distribution and Laplace equations, how the atom is there, whether it may be cylindrical shape or circular shape or rectangular shape, all these things makes predominant role. Suppose if you have to take a quantum mechanics, this entirely abstract thinking. Now we are discussing about the electronics. Electronics is the application of physics subject. Nowadays, without electronics, no house is there, no person, your mobile, your TV, your laptop, your pen, your watch, everything based on the electronics only works. Clear? So that's why electronics is a pacemakers in human life. In human life, electronic devices can act as a pacemaker. That's why electronic industry is very important to develop the country, to develop the nation. These electronics goods also takes place major role. Nowadays, we have to take the drones, visuals. In the drones, electronic goods only we are using. What is the syllabus is there in CSIR and GATE examination to prepare the electronics? This is very easy. Electronics is very easy. Once you listen this demo or introduction class, you decide. So please share and subscribe my YouTube channel. To be subscribe your friends also. If you are interested, you go to the App Store, Google Play Store, you have to go and download Quantum Online app. From that app, you have to purchase the CSIR and GATE physics all branch course you have to take. After some days, individual papers also we will make it as a courses. But now we make it only one course, that is the bulk. All 9 papers, physics 9 papers will be there in that course. Okay. After some time, I will inform you. Now you have to listen. CSIR and GATE, electronics and experimental methods are there. Today we are going to discuss about the syllabus of the electronics and experimental methods in CSIR, paper pattern, solutions of the some old questions in GATE or CSIR. Today all CSIR questions only I took. Now you have to see what is the syllabus is there. Now we will see CSIR, 2 parts of the syllabus are there in 6 papers. What are those 6 papers? Once you have to see. First, mathematical methods of physics. Mathematical methods of physics, core and advanced part is there. Next, classical mechanics. In classical mechanics also core and advanced is there. Next, electromagnetic theory. In electromagnetic theory paper also core and advanced is there. The 4th one is quantum mechanics. In quantum mechanics also core and advanced is there. The 5th one is thermodynamics and statistical mechanics. Thermodynamics and statistical mechanics. This one also core and advanced is there. And the 6th one is electronics and experimental methods. Electronics and experimental methods. This paper also core and advanced part is there. These 6 papers, core and advanced part is there. Please remember, mathematical methods of physics, it is very important. Already we uploaded in YouTube. Classical mechanics, this one also we uploaded in YouTube. Electromagnetic theory, we uploaded in YouTube in our channel. Quantum mechanics it will come, thermodynamics and statistical mechanics, and electronics and experimental method. These six papers has core and advanced syllabus is there in CSIR. Clear? Now we will see. Already we discussed, we uploaded atomic and molecular physics. This is the first one. Condensed matter physics. This one is the second one. The third one is nuclear and particle physics. Nuclear and particle physics. These three papers only advanced syllabus. Only advanced syllabus. Please remember, mathematical methods of physics, classical mechanics, electromagnetic theory, quantum mechanics, thermodynamic and statistical mechanics, electronics and experimental method. In CSIR, there is a two parts are there. One is core, part A, another one is advanced, part B. Part A is the core syllabus, part B is the advanced syllabus. Both parts are there. But these three papers, atomic and molecular physics, condensed matter physics, nuclear and particle physics, these three papers in CSIR, only advanced questions only it will come. Only advanced questions. Only 3 questions from AMP, 3 questions from condensed matter physics, 3 questions from nuclear and particle physics. This one is consisting of 15 marks. This one contains 15 marks. This one also contains 15 marks only. Clear? Only 15, 15, 15. 30 marks for these 3 papers weightage. Rest of the 30 marks, out of 170, 140 marks. 140 marks will come from these papers only. Only 6 papers will give 140 marks in CSIR. These papers will give only 30 marks in CSIR. Clear idea? You kept. Now we will see the core syllabus. CSIR part A core syllabus is there. What is the core syllabus? So once you have to see. First, semiconductor devices. Semiconductor devices. On the semiconducting material, diodes you can keep, diode junctions, transistors, field effect transistors, homo and hetero-junction devices. Up to here, semiconductor devices only. Up to here, semiconductor devices only. Later, in semiconductor devices only, what we have to learn? Device structure we have to learn, device characteristics we have to learn, frequency dependence and applications we have to learn. Up to here, semiconductor, this is only one part only. From semiconductors, semiconducting devices, suppose you have to take a silicon is a semiconductor, silicon, germanium, these are the semiconducting material. You have to take the silicon. On the silicon, you have to make a device, whether it may be diode, transistor, field effect transistor, hetero-junction transistor, homo junction transistor, whatever the device you like, that device you have to deposit on that. Clear? That is the semiconductor device. Each and every device, device structure you have to learn, device frequency response you have to learn, device IV characteristics you have to learn, everything, whatever the information is there, whatever the advantages from the devices. Suppose you have to take a diodes. Diodes, how it will be useful? Diode can used as a rectifiers. Suppose you have to take a field effect transistor. Field effect transistor, which purpose we are using? Transistor, which purpose we are using? Like that we have to learn each and everything in a semiconductor device. Later, so second one is optoelectronic devices. Optoelectronic devices, their solar cells, photo-detectors, LED, light emitting diode. In optoelectronic devices, optoelectronic means by using the optical energy, we are converting the electrical energy. Suppose you have to take a solar cell in once you have to go on the road, every corner of the traffic they are keeping as a solar panels. Why? Which purpose they are keeping the solar panels? to produce the electrical current. Bulb need to illumine, how it will be illumine the bulb? Because of the optical energy incident on the solar panel. Solar panel will absorb the optical energy. It convert into the electrical energy. That electrical energy indicated the bulb only. That one is optoelectronic devices. That's the second part. There solar cells are there, photo-detectors are there, LEDs are there. Next you have to see the third one is operational amplifiers. In operational amplifiers and their application. Operational amplifier means inverting amplifier, non-inverting amplifier, summing, subtraction amplifier, differentiating amplifier, integrating amplifier, logarithmic amplifier, anti-logarithmic amplifier, like that. Whatever the operations, mathematical operations we are doing, so operations we are getting through op-amps, operational amplifier, electronic devices. So that's why we call it as a operational amplifiers, and applications also we have to learn from that. Next, fourth one is digital techniques. In digital techniques and applications, in digital techniques, resistor to store the data, we need the resistor. Counter to count the pulses, we need the resistor. Comparator, we have to compare it between the two devices, we have to use. Similar like that circuits, logical circuit, mux and demux, coder, encoder, all those things we have to learn from here, right? That one is a digital techniques. Now the fifth one you have to see analog to digital, digital to analog converters, analog to digital, digital to analog converters. Now sixth one, microprocessor and microcontroller basics. Microprocessor and microcontroller basics is needed. Later, this entire syllabus is electronic syllabus. Now you have to see data interpretation and analysis. This one is experimental method. Precision and accuracy, error analysis, propagation of errors, least square fitting. Least square fitting, data interpretation and analysis, precision and accuracy, error analysis, propagation of errors, least square fitting. There is a formulas are there to fit the all this data. This is syllabus of the core syllabus. This is very important syllabus. Core electronic syllabus is very important. If you learn this electronic syllabus, you will get the more perfection. More perfection you will get. This is very important. Clear? Now we will see the advanced part. What is the advanced part? Once you have to see. That advanced part in CSIR, linear and non-linear curve fitting. This one also experimental methods, chi-square test, transducers, temperature transducer, pressure and vacuum transducer, magnetic field transducers, vibrational transducers, optical transducers and particle detector. Suppose you in your laboratory GM counter is there. GM counter can act as a particle detector. These are the curve fitting, non-linear curve fitting and linear curve fitting, chi-square test, transducers. Measurement and control electronic devices, signal conditioning recovery devices and impedance matching, amplification based on op-amp based, instrumentation based op-amp, feedback based op-amps you have to use. Filtering and noise reduction, shielding, grounding, Fourier transforms. This entire thing is there. That experimental methods only. Electronic based experimental methods. Please remember electronics based experimental method. Now you have to see that in part B, there is a advanced part is there in the electron, that is lock-in detectors, boxcar integration, boxcar integrator, modulation techniques. There are three varieties of modulations are there: phase modulation, amplitude modulation, frequency modulation, phase modulation, amplitude modulation, frequency modulation. How the modulation techniques are there, those things also will come in CSIR examination. High frequency devices including the generators and detectors, high frequency devices, maybe radio frequency devices is there. Those devices also we have to learn from part B. Part B is the advanced part. Part A is a core part. Somewhat in your MSc, this syllabus you won't learn. Maybe you have to learn from part A. What is that? Semiconductor devices, optoelectronic devices, op-amps, digital to analog and analog to digital converters. You learn up to there only. Some minor part, microprocessor and microcontroller you learn. Up to MSc you have to learn this much of the syllabus. Data interpretation and analysis, precision and accuracy, error analysis, propagation of errors, least square fitting. This one is not covered in your MSc level. Now this entire syllabus also not covered in your MSc level. If you are expert, specialized in electronics, there this syllabus is there, but a general MSc people, for general people, this syllabus is not covered. That's why you need the coaching. If you like my teaching, you download my app, that is Quantum Online Academy app from your Play Store, and you purchase the course, then you listen the classes, right? Now you have to see the exam pattern, CSIR exam pattern, how it will be. Here 3 sections are there. The section A contains general aptitude, that general aptitude with emphasis of logical reasoning, graphical analysis, analytical and numerical ability, quantitative comparison, series formation and puzzles. You will get the 20 questions in CSIR, 15 questions you have to do. Each and every question you will get the 2 marks for right question. Each and every wrong question you may lose 0.5 marks. How many marks you have to get here? 30 marks for general aptitude. Total 30 marks are there. Now part B. Part B, electronics questions will come, right? Electronics questions will come. How many questions? Maybe 2-3 questions from part B also you will get in CSIR. Total 25 questions. Out of 25 questions, you have to attempt 20 questions. Each and every question carry 3.5 marks. Each and every wrong question, you may lose 0.875. Total how many marks you will get? 70 marks you will get from part B. Now I am coming into the part C. In advanced part also, electronics questions will come from advanced part also. Total 30 questions they will ask. 20 questions you have to attempt. For each and every question 5 marks. Each and every wrong question you may lose 1.25 marks. Total how many marks you will get? 100 marks you will get in this section. That's why I told 170. Total 170 marks you will get from physics only. 170 marks you will get from physics only. If you get 100, out of 170, if you get 100 marks in your competitive exam, you will get first rank in throughout India in CSIR. Please concentrate and read. You will get the CSIR Pakka. Now GATE. GATE, what is the GATE? Previously, this electronics paper along with condensed matter physics. Electronics paper, they are combining with the condensed matter physics. We will see the GATE. In GATE, previously this was condensed matter physics along with electronics was there. But now they changed for 2024 February GATE. They changed, they are divided, the electronics is divided along with the condensed matter physics. Now they segregated 9 papers in CSIR, similar fashion 9 papers in GATE examination also. Clear? Now we will see in electronics, in GATE, which syllabus is there you have to see once. Semiconductors in equilibrium, you have to take it as a semiconductors in equilibrium. Electron and hole statistics in intrinsic and extrinsic semiconductors, metal semiconductor junctions, ohmic and rectifying contacts, PN diodes, bipolar junction transistors, field effect transistors, negative and positive feedback transistors, oscillators, operational amplifiers, active filters, basics of digital logic circuits, combinational and sequential circuits, flip-flop timers, counters, resistors, AD and DA conversion, analog to digital conversion. So entire the syllabus is there in CSIR except experimental methods and microprocessor and microcontroller. Microprocessor and microcontroller in GATE syllabus is not there. In CSIR syllabus, microprocessor and microcontroller also is included. Clear? Now once again you have to see semiconductors in equilibrium, electron and hole statistics in intrinsic and extrinsic semiconductors, metals and semiconductor junctions, ohmic and rectifying contacts, PN diodes, bipolar junction transistors, field effect transistors, negative and positive feedback circuits, oscillators, operational amplifiers, active filters, basics of the digital logic circuits, combinational and sequential circuits, flip-flops, timers, counters, resistors, analog to digital, digital to analog conversion. Okay, clear? So this syllabus is the GATE syllabus. How the exam pattern? Exam pattern here 2 sections only is there. One section for general aptitude, one more section for physics. So that general aptitude section you have to see only 15 marks you will get in general aptitude. 1 to 5th question you will get 1 mark question, and 6th to 10th question you will get the 2 marks questions. Each and every question from question number to 6, 2 marks question. Total how many marks? 15 marks from general aptitude. Clear? Now physics you have to see total 85 marks are there. Total 100 marks paper. GATE is 100 marks paper. Among 100 marks paper, 15 marks for general aptitude, 85 marks for physics. First 11th to 35. Question number 11 to question number 35. Each and every question shall carry 1 mark. Question number 36 to 65. Each and every question shall carry 2 marks. There are 3 varieties of questions are there. One is multiple choice question. Second one is multiple selected questions. The third one is the numerical answer type question. Now you have to see multiple choice question. Already I told among the 4 options A, B, C, D options are there. Among the 4 options you have to select one option. Whether it may be A correct, you have to select A. Such type of questions we call it as a multiple select question, multiple choice question. Next, multiple select questions are there. What are those multiple select questions? Suppose you have to take A comma, B comma, C comma, D is there. So 3 questions you make correct. You have to attempt for 3 only, right? You select for 3. If it is 3 correct, you select for 3. Numerical answer type questions. If it is how to take the answer, that answer you have to enter, whether it may be 1, 2, 3, whatever it may be there, that answer you have to enter. That is a numerical answer type question. This for this question there is no negative marking. No negative marking. Please remember, you must attempt the numerical answer type question. You won't get any negative mark. You won't lose any negative mark for a numerical answer type question. This is the exam pattern of once again we have to see what is the syllabus in CSIR. In CSIR and GATE, there is a paper is there, electronics and experimental methods. There you have to see electronics and experimental method. 2 varieties of sections are there in core A. Core A is electronics and experimental physics. That entire syllabus is this one only. Suppose you have to see the core B. So that one is advanced syllabus. Electronics and experimental method syllabus is there. That is majority portion from experimental side. Linear and non-linear curve fitting, chi-square test, transducers and measurement and control, signal condition and recovery, impedance matching, amplification. All these things are there, no? These things are experimental methods only. Lock-in detector, boxcar integration, modulation techniques, high frequency devices are there. These from advanced part. All these things from advanced part. This is the pattern. Every time I told, this one is the gate. Which one is there, Nana? Gate electronic section 8. That is similar, almost similar syllabus is there. Now you have to see the pattern of the gate. General aptitude 15 marks, physics for 85 marks is there. Now you have to see the reference books. Syllabus is very vast. Books also you won't get within a single book, you won't get entire syllabus. You have to follow for each and every content, for every content you have to follow different books. Sometimes each and every topic also you have to follow different varieties of books. Suppose you have to see here, electronic devices and circuit theory, Boylsted and Nestlesky. This book is very nice book. Boylsted book is very nice. This book size is huge, size is there. If you want to buy, you have to buy this book. This book is very good. Electronic devices and circuits, Jacob Millman and Alkis. This book is yellow color book. This book is very nice. Fundamentally, you have to buy this book, Electronic Devices and Circuits. These books will help you more from foundation side. Digital Electronics, Melvino Leach. This book is Bible for the digital electronics. Melvino Leach is very important book. Basic Electrical Engineering Scam Series, Jimmy Cathay and Syed S. Nasser. This book also very nice book. All problems are there in Basic Electrical Engineering Scam Series. Linear Integrated Circuit, Dr. Roy Chowdhury, Shail B. Jain. This is Indian author book. This book also good for linear integrating circuit, operational amplifiers and application of the operational amplifier you will get from this. Experimental Methods for Engineers, J.P. Holman. For experimental physics, experimental techniques you have to follow this one, J.P. Holman. Data reduction and error analysis for the physical science, Philip R. Bovington and Keith Robinson. This book also very nice book, Data Reduction and Error Analysis for a Physical Sciences. These 7 books, 7 different topics for purpose you have to refer these books. Otherwise, you have to take this course, you will get entire the thing. Once again, I am reminding you, so that batch initially, previously we want to start at the 7th, but even though that course is started, okay, we uploaded whatever the things are there in YouTube, those things we uploaded in app also. From app also free content is there. From app also you have to listen all these introduction classes. Clear? From 18th onwards, seriously, we have to start live come recorded classes. Morning 6 AM to 8 AM, that is the live. If it is live is not present also, no problem. That class is available in the app only. In recording mode is available. Whenever you are free time, that time you have to learn that course. Clear? That is the CSIR and GATE physics batch will start from after Pongal 18/1/2024 onwards. If you have any doubt, you want to negotiate the fees, you contact my numbers. My numbers are 9908437460. This is my personal number. My institute number is 630-326-3368. Otherwise, you have to call to the institute number also. You know how the procedure is there. You go to the Play Store in your mobile app. This is a mobile app. In system also it will come. Any Android version it will come. Go to the Play Store and download the Quantum Online Academy app. The symbol will be displayed like this. You download it and you listen my classes. These free content also available in that class. No problem. You have to listen from that. Now, this entire syllabus I segregated in 10 parts. How many parts I segregated? Total 10 parts I segregated. Once you have to see here. First, semiconductor devices. Their diodes, transistor, field effect transistor, and their applications and frequency responses, entire the thing will cover in semiconductor devices only. How many marks you will get in CSIR? 5 marks you may get, 1 mark in GATE examination. From optoelectronic devices also same thing, 5 marks you may get in CSIR examination, 1 mark in GATE. Operational amplifiers and their application, this is very important for both CSIR and GATE. Both cases this one is very important. 5 marks in CSIR, 1 mark in GATE you will get. Digital techniques and their applications, this one also very important. Compulsory question will come in any competitive exam, whether it may be belongs to the electronic syllabus. This digital techniques, then from their application also you will get 5 marks in CSIR and 2 marks in GATE examination you will get. Analog to digital and digital to analog converter, this one also very important. How we have to convert digital to analog and analog to digital. The 5 marks you may get in CSIR, 1 mark in GATE you have to get. Microprocessor and microcontroller, updated version of the microcontroller is only our computer. That's why this is also important. Recently all the competitive people are following these questions also. Locking detector, boxcar integrator and modulation techniques. This one also very important. Questions pakka they are asking from this is advanced syllabus of the CSIR. Locking detector or locking amplifier also we call it as boxcar integrator and modulation techniques. 5 marks in CSIR, 1 mark in GATE. Data interpretation and error analysis, you will get 3.5. 3.5 in CSIR examination. There is no GATE, 0. There is no syllabus for 0. Here also 0. Syllabus is modulation techniques is there. So they will ask modulation techniques. 1 mark you may get. 1 mark you may get here. But here there is no syllabus. Transducers also there is no syllabus. Sometimes impedance matching you will get the both syllabus is there. Amplification, that is 3.5, 3.5. This is the segregation. You have to segregate like this. You read. It will be easy to learn the electronics. How each and every area how to take one question. From semiconductor devices, 1 question I took. Optoelectronic devices, 1 question I took. Operational amplifier, 1 question I took. Digital techniques and data, digital to analog and analog to digital converter, lock-in detector, data interpretation, transducers and impedance matching. From each and every section, I took one question. You have to listen carefully. Sometimes from this area question will come, you will get benefited in your competitive examination. Clear? Now we will see how the questions are coming. The VI characteristics of a diode. The VI characteristics of a diode in the circuit below is given by I is equal to, they are giving I is equal to V minus 0.7 is divided by 500. This is the I value. For V is greater than or equal to 0.7. This is the diode. This diode voltage you have to take it as a V. On the diode voltage you have to take it as a V. Where V is measured in volts and I is measured in amperes. Then the current I is how much current I? That I we have to calculate. From this diagram, which one we have to calculate? I we have to calculate. How we have to calculate? This is a loop. We have to follow the mesh analysis or loop analysis. How we have to follow the loop analysis once you have to see. First you follow the clockwise direction. From this clockwise direction, this is the negative side. This one is a positive side. Now I am following the flow of current like this. If you have to take, this is a positive, this one is a negative, sorry. This one is the negative is there. From negative to positive, that's why you have to take it 10 volts first. Minus, this one how much resistance is there? 1k ohm, means 1000 ohms. 1000 into I. I is equal to, which one you have to write, Nana? V minus 0.7 is divided by 500 minus How much voltage is there here? V voltage is there, is equal to 0. Why I am writing the minus? This is the diode positive, this one is the negative. It is ending with the negative, that's why I have to take it as a minus. There is a sign convention is there. Once you have to join in our course, we will teach how we have to follow, how we will get entire thing. Now from this you have to calculate 2 0 2 0 get cancel, 5 1 ja 5 2 ja, 10 minus 2 into V minus into minus plus 0.7 into 2 minus V is equal to 0. According to Kirchhoff voltage law, summation of V is equal to 0. From this we have to write according to the loop analysis. From this minus V minus 3V plus 1.4, this 1.4 plus 10 is equal to 11.4 is equal to 0. V is equal to, how much we have to get, Nana? 11.4 is divided by 3. 11.4 is divided by 3 is equal to, how much you have to get? 3.8 volts. We calculated. But what they are asking? I they are asking. Then the current I. I is equal to, which one they gave? I is equal to V minus 0.7 is divided by 500. V is equal to, now we calculated 3.8 minus 0.7 is divided by 500. Once you have to calculate this one, how much you will get? 3.1 is divided by 500. 3.1 is divided by 500 is equal to how much? 6.2 milliamps. How much answer you have to get it? 6.2 milliamps. Once you have to see what is your answer. This answer is correct. Option C is correct. Clear? Very simple. First you see the loop. This is a loop. Follow the Kirchhoff voltage law. If it is a loop, you have to follow the Kirchhoff voltage law. If you have to take a node, you have to follow the Kirchhoff current law. Along the loop, once you have to see. Now I am following one direction, that is which direction it is? Clockwise direction I am following. Which one is ended? Plus. That's why I took plus 10 volts. Minus I into R. R into I is equal to V. Voltage along the resistance I have to take. Voltage along the diode I have to take. From that I calculated the V. Later I substituted in I. Therefore you will get the I value. How much I value are getting? 6.2 milliamps. When they asked this question, December 2014 in CSIR examination, this question was there. Very, very important. Very simple. If you know the logic, how we have to solve this one, very simple. You don't know any technique, you don't know anything, even though you will get the answer. Clear? Now we will see the second one. What is the second one you have to see? From optoelectronics. What is optoelectronics? A LED. LED means light emitting diode. LED, these are the LED bulb, and light emitting diode operates at 1.5 volts. This light emitting diode is operating at 1.5 volts, and current, how much current is there? That current is equal to 5 milliamps. We are getting the forward bias. Assuming an 80% external efficiency is equal to 0.8. 80% means 0.8 of LED. How many electrons are emitted per second? How many electrons are emitted per second is equal to N is equal to how much they are asking. What is the power? Power is equal to energy per second, we call it as a power. Power we have to write it as power is equal to N into h nu. What is the N? N is a number of photons emitted per seconds. Number of photons per second. Number of photons emitted per second. P power is equal to N into h nu, where N they are asking, N is equal to power input power is divided by h nu we have to write, but power is equal to we know, but power is equal to one formula is there, that power in is equal to eta external into I h nu is divided by q. Eta h nu, I h nu is divided by q is there, eta external into I h nu is divided by q is there. This is the power in or power out also, that formula we have to write, power in or power out also. You have to substitute this formula here. N is equal to eta external into I h nu is divided by h nu into q. H nu get cancelled. Therefore, N is equal to eta external into I is divided by q. Now you have to substitute. Eta external is equal to how much, Nana? 0.8. I is equal to how much? 5 into 10 to the power of minus 3 amps is divided by q is equal, that is electron, 1.6 into 10 to the power of minus 19 coulombs. 0.8, 0.2 to 1 ja to 2.5 jas. 10 to the power of minus 19, it will goes to the 10 to the power of plus 19. Therefore, how much you all get? 2.5 into 10 to the power of 16 you are getting. This is the number, photons per second. Therefore, what is the answer? Your answer is D, 2.5 into 10 to the power of 16. Like this we have to calculate. You know the formula. You have to apply the formula. Answer you will get easily. What is the answer? 2.5 into 10 to the power of 16 photons per second that LED emits. That is the thing. Now we will see the third one. An operational amplifier based on voltage follower. You have to take a operational amplifier based on voltage follower you have to take. Which one is correct? June 2014 time they are asking the question. It is a theoretical question. Voltage follower. Which one it is, Nana? Voltage follower. Voltage follower. How it will be there? Voltage follower. A voltage follower circuit. This is one we call it as a buffer amplifier, also we call it as buffer amplifier. Buffer amplifier. This one we also call it as buffer amplifier. This voltage follower gain is equal to 1. This voltage follower feedback resistance is equal to 0. How the circuit will be? This voltage follower circuit is a non-inverting amplifier. You have to take it is a non-inverting amplifier. You have to take V output, V input. You have to take the non-inverting port side. This is one is V input. Clear? So once you have to take, there is no feedback resistance here is there. Suppose here input impedance. Suppose you have to take it is a converting. Input impedance is very high. Input impedance is high. Input high impedance, right? Input impedance is high. Output impedance is low. That is the voltage follower. Output impedance is, which one it is? Output impedance is low. Which option is correct? It is useful for converting the low impedance source into the high impedance. Wrong. Option A wrong. Option B is correct. It is useful to the converting a high impedance source into low impedance source. Option B is correct. These are the options you have to remember. This is very, very important. Operational amplifier can act as a voltage follower. This is the one of the application of a operational amplifier. Sometimes they may ask logarithmic amplifier. Sometimes they may ask anti-logarithmic amplifier. Sometimes they may ask differentiator. Sometimes may they ask integrator circuit. Any question they will ask, I choose this one. All the questions came in CSIR examination. Now you have to see the digital technique question. A 4 variable switching function is given by a 4 variable switching function is there. What is the function? Once you have to see, f is equal to a 4 variable switching function, f is equal to sum of 5 comma 7 comma sum of 5 comma 7 comma 8 comma 10 comma 13 and 15 plus don't cares are there 0 1 2 don't cares are there, where D is the do not care condition. The minimized form of the sum product form is what is they are asking. What is the minimized form? Is equal to how much? This is the bigger form. Now you have to take a Karnaugh map. K map you have to take. How many variable K map? Whether it may be 15 is there, no? 4 variable K map you have to take. Now I am bringing the 4 variable K map. Once you have to see here, how I am bringing, this is AB. This side you have to take it as a CD you have to take. CD, which one you have to take? AB I have to take this side. CD you have to take this, sorry, you have to take 7 and 8. AB you have to take this side. CD you have to take this side. How many variables? 4 variables. 0, 0, 0, 1, 1, 1, 1, 0. It is, you have to take like this. 4 boxes you have to take. 0, 0, 0, 1, 1, 1, 1, 0 is there. Which one how we have to write? If it is 0 complement port, sum of product, 0 complement, A complement B, A, B, A, B complement, right? Now you have to write C complement, D complement, C complement D, C, D, we have to write C, D complement you have to write. Now you write the values. How you have to write? 0, 0, 0, 0, this value is 0. 0, 0, 0, 1, this value is 1. 0, 0, 1, 1, this value is 3. 0, 0, 1, 0, this value is 2. 0, 1, 0, 0, this value is how much value, Nana? 0, 1, 0, 0, this value is 4. 0, 1, 0, 1, this value is 5. 0, 1, 1, this value is 7. 0, 1, 1, 0, this value is 6. Now you have to see 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 0 is equal to how much? This value is 12. 1, 1, 0, 1, this value is 13. 1, 1, 1, 1, this value is 15. Obviously this value it will come, how much it will come? This value is 40. Now you have to see 1, 0, 0, 0, this value is 8. 1, 0, 0, 0, this value is 9. 1, 0, 1, 1, this value is 11. 1, 0, 1, 0, this value is 10. Now you have to, now we are writing this is a 4 variable Karnaugh map. In 4 variable Karnaugh map, which value they are giving? Wherever the 5 is there, there 1 you have to keep. 5, 1 we have to keep. Wherever the 7 is there, 1 you have to keep. 7, 1 you have to keep. Wherever the 8 is there, 1 you have to keep. 1 you have to keep. Wherever the 10 is there, 1 you have to keep. 1 we are keeping. Wherever the 13 is there, 1 you have to keep. Wherever 15 is there, 1 we have to keep. Next I am coming into the don't care conditions. Where 0 is there, don't care condition. 1 is there, 1 is a don't care condition. 2 is there, don't care condition you have to keep. Now you group. How we have to group? Once you have to see. First there is a quad. Quad you have to group. This grouping we call it as a quad. 4 terms are there at a time, that grouping we call it as a quad. Next corner group you have to group it. This is also quad. Corner quad. Which one it is? Corner quad. Corner quad. This grouping we call it as a corner grouping. First we are grouping 2 types of group. Now we have to write once. How we have to write once, you have to see. First vertically you see. Which is the similar term is there? Here 1 is there, here 1 is there. Which one this is? This one is the D. That's why you have to write here D you have to write. First vertical we saw. Now horizontally you see. Horizontally from this and this you have to see. Which is similar? 1 is similar. Which one is that is? B you have to write. What are the similar terms are there? Those terms you have to write. Whatever the different terms you have to leave it. Similar terms 1, 1. So here also which one is there? 1, 1 is there. BD I am writing. According to this quad, BD is there. Similarly, now I am coming into the corner grouping. In corner grouping, once you have to see this one 1, 0, this one 0, 0. So 0 is similar. 0 belongs to whom? B bar. 0 belongs to B bar. Now I am coming into this side. Again I am coming into the vertical. Here 0, 0 is there. Here 1, 0 is there. Which one is similar? 0, 0 is similar. 0 belongs to whom? D bar. Therefore, D bar. Therefore, the minimized function f is equal to BD plus B bar D bar. BD plus B bar D bar. What is the option? Option D is correct. Which option is correct? Option D is correct. Very simple. If you know the Karnaugh map, you have to apply the Karnaugh map. Easily you will get the answer within 1 minute. Fraction of minute you have to get the option. So you have to take wherever, if it is a sum of product, you have to take it as a 1 as a number, 0 as a complement you have to take. If it is product of sum, reverse you have to take 0 as a number and sum as a complement you have to take. This one is your correct answer. Now we will see the next question. This one is which one? Digital techniques question only. Analog to digital and digital to analog. The full scale voltage of an n-bit digital to analog converter is V. The resolution that can be achieved. The resolution of full scale n-bit digital to analog converter. This is very, very important. The resolution of, which one we have to take? The resolution of full scale n-bit digital to analog converter. Digital to analog converter is equal to, which one we have to write, Nana? V is divided by 2 to the power of n minus 1. This is the formula for resolution. Which one it is? This is the formula for a resolution of full scale n-bit digital to analog converter. Just simply formula they are asking for 5 marks. When they are asking this question is asking December 2017. December 2017 in CSIR examination. That time this question was asked V by 2 to the power of n minus 1. This is very, very important. Please concentrate on this. Next, one more thing you have to see. A dash is a group of connecting wire that connect through the CPU with other peripherals like memory, input-output ports and other supporting components. Whether it may be timer or controls, counters, not correct. Serial port, not correct. Analog to digital, not correct. That is a system bus. A system bus, suppose you have to see, this is the CPU. This one is the memory. This one is the output and input port. This system bus, CPU, memory, input and output port connects. Maybe you have to take a data bus and address bus. You have to take this one. Next, this total one you can calculate it as a system bus. Which bus it is? System bus. This is very, very important. When they are asking, recently they are asking TSPSC, JL physics examination, they are asking this question. System bus can interacting with the CPU input and output ports and memory ports, right? These are very, very important one. Now once again you have to see here. Two sinusoidal signals are sent to an analog multiplier of the scale factor 1 voltage inverse, followed by a low pass filter. If the rollout frequency low pass filter is 5 Hz, the output voltage is how much? Now, how we have to calculate? Which type of question it is? This question belongs to the lock-in amplifier question. Which question it is? Lock-in amplifier. This question belongs to the lock-in amplifier question or lock-in detector question. Lock-in amplifier or lock-in detection. How we have to approach? Here two inputs are there. One is input function, that is this is input beam. V1 is equal to, how much is there in an input beam? 5 cos 100t. This is a input beam. Now another one is there. This one is a reference input. This input we call it as a reference input. Reference input. How much is there? V2. V2 is equal to 20 cos 100t plus 5 by 3. 20 cos 100t plus 5 by 3. These two inputs are multiplied by using a multiplier. This is a multiplier. What is this? This is a multiplier. Therefore, V is equal to V1 into V2 with how much? 1 voltage inverse we have to multiply. That is a multiplier is analog multiplier. The scale factor is equal to 1. Now, after getting this, there is a low pass filter we are using. What is the low pass filter? Low frequencies are allowing, low frequencies are allows and high frequencies are ceases. High frequency, this concept is very important. High frequencies are stops. High frequencies are stops. How we have to get after low pass filter? How much voltage after low pass filter? How much voltage output is there? That is our ultimate goal. Once you have to see. First V output is equal to, first you have to take a from multiplier, I have to take multiplier output. Multiplier output you have to take. Multiplier output you have to take. V1 into V2 into multiplication factor. This is the formula. V1 is equal to how much? V1 is equal to 5 cos 10t. 5 cos 100t. V2 is equal to, how much is there? V2 is equal to 20 cos 100t plus 5 by 3. 20 cos 100t plus 5 by 3 is there. 100t plus 5 by 3. Now you have to multiply. This is the 5. This one is a 20. Is equal to 100 into cos 100t into cos 100t plus 5 by 3. Cos 100t plus 5 by 3. Now you have to multiply with 2 divided with 2. Right? How I am taking ones? 2 1 ja 2 50 we are getting. 50 into 2 cos A cos B. This one you have to take cos A cos B. 2 cos A cos B is equal to cos of A plus B 100t plus 100t plus 5 by 3. Clear? 100t plus 5 by 3. Cos of A plus B plus cos of A minus B. Cos of 100t minus 100t minus 5 by 3. This is a cos of A minus B. Now cos of A plus B is equal to 50 into cos 100 plus 100 is equal to 200t plus 5 by 3. Right? Plus cos 100 plus 100 minus 100 get cancelled. Cos of minus theta is equal to cos theta, cos phi is equal to 180 degrees. How many degrees you are getting? Cos 60 degrees you are getting. Now you have to simplify. How much you have to get it here? You have to see V multiplier is equal to V multiplier output is equal to 50 into which one we have to write? You go you take inside cos 200 t plus 5 by 3 plus 50 is divided by cos 60 is equal to 1 by 2. You are getting here. How much you are getting? 25 you are getting. Clear? 25 you are getting. Now you apply the low pass filter. Which one you have to apply now? Low pass filter. This one is a 50 into low pass filter you have to apply. What will happen? Where is the high frequency is stages? High frequency ceases. High frequency stops or ceases. High frequency stops means this one is stops. Which one is out? After low pass filter, the output voltage is equal to only 25 is there. That 25 volts will come out. Like this we have to calculate. It is very simple. 5 marks you will get. There is no external mathematics is there. What is your option? Option B is correct. This question belongs to lock-in detector. Which purpose we are using the lock-in detector? To measure a small AC signals. Maybe compared to the less than the nanoscale, we have to measure by using a lock-in detector. Suppose some noise is there, no? That noise also takes place here major role. This is very, very important one. 5 marks you may get from lock-in detector. Now we will see the questions. These questions are very, very important questions. Which type of questions once you have to see? Experimental methods. We are taking the 3 questions. That one you have to see. The experimentally measured values of the variables x, y are experimentally measured values. X value they are measuring 2.00 plus or minus 0.05. Y is equal to which one they are measuring, Nana? 3.00 plus or minus 0.02 respectively. What is the error in the calculated value? Z is equal to 3y minus 2x. The propagation error we have to calculate. The propagation error, there is a formula is there. Propagation error is equal to sigma z square is equal to dou square z by dou y square, dou z by dou y whole square into sigma y square plus dou z by dou x whole square into sigma x square. This is the formula. From this formula, how we have to calculate once you have to see. First, dou z by dou y you have to calculate. Dou z by dou y is equal to how much you will get it? Dou z by dou y is equal to 3. Dou z by dou x is equal to how much you are getting, Nana? Minus 2. Next, you have to substitute sigma y, sigma x, there is a sigma x is there. This is the error distribution. Sigma y, there is a sigma y is there. That is the error distribution. Now you have to substitute in this formula. Sigma z square is equal to dou z by dou y whole square means 3 square into sigma y. With respect to y, how much is there? 0.02 whole square plus dou z by dou x whole square is equal to minus 2 whole square into 0.05 whole square. You calculated 9 into 0.00. So 002 means 4. You have to take it as plus which one? 4 into 0.0025 you are getting. Now you multiply this, you calculate the sigma z square. Sigma z you have to calculate. Sigma z is equal to, that is the propagation error. You will get 0.12, you will get it. Clear? So sigma z square you have to calculate, and then you have to find the root 2. So root of that square root, you will get that one. What is the answer? 0.12 is your answer. Option A is correct. When they asked June 2017, they are asking in which exam? CSIR exam. For how many marks? 3.5 marks. How simple is there? You have to see. Very simple. Electronics is very simple once you come to know. Now you will see the ninth one. This one is a transducers. Transducers matlab we have to measure the temperature measurement, pressure measurement, voltage measurement. You have to take a vacuum tubes, that vacuum tube measurement, how much gas is there inside, like that we have to measure. Now you have to see a sensitivity of hot cathode pressure gauge is sensitivity they are giving. Sensitivity is equal to 10 millibar volt to the power of -1. The ratio between the number of the impinging charged particles, which one we have to take? Impinging charged particles to the number of, which one it is? The impinging charged particles to emitted electrons. This is a ratio. Impinging charged particles to emitted electrons you have to take. This ratio they are giving, what is that? 1/10. Which one they are asking? What is the pressure they are asking? The pressure gauge is equal to 1/S into number of impinging particles, that is the input particle, impinging particles, I impinge I am writing, impinging particles is divided by I emitted particle. Now just you substitute, you will get, this is the formula. Just you substitute, you will get the 3.5 marks. 3.5 marks in CSIR exam. How simple it is, you have to see. 1/S is equal to 1/10 millibar whole universe, right? Next, I impinging is divided by I emitted, also 1/10. 1/10, 1/100. It goes to numerator 10 to the power of -2. This is the -1. It goes to the numerator millibar. You are getting 10 to the power of -2 millibar. What is your option? Your option C is correct. How simple it is, you have to see. Just you know the pressure gauge. Pressure gauge formula is equal to 1/S into impinging charged particles by emitted charged particle. I impinging charged particle is divided by I emitted charged particle. That one you have to substitute. You will get the answer. This is very, very important one. Now we have to see the last one. In an electronic circuit, matching means, this one APDL 2012 they are asking this question. In an electronic circuit, matching means, what is the matching? Matching means when R incident resistance is equivalent to load resistance, when it will be give the amount of maximum power, maximum power should be transfer. The amount of maximum power transfer, when it will be transfer, when Ri is equal to RL. Such type of device we call it as a impedance matching device. Now option A you have to see, connecting a high impedance directly to low impedance, this is not correct. Transferring the maximum amount of signal. Between two different kinds of circuit Option B is correct. So according to the what is the matching? Matching means whatever the maximum power which input you have to take the resistance, that input resistance you appear maximum power you will get wherever the load resistance you have to take that much of load resistance time, you will get the maximum power is transferred from that device. Such type of circuit we call it as a impedance matching circuit. Clear? This is the electronics questions. These electronics questions are very easy. How you have to feel my teaching, we don't know. So, but you decide. Our CSIR and GATE batch is started. Already we started in app. You download the app. You go to the Play Store. Download the app, Quantum Online Academy app. From that app, you have to listen my classes. Those classes are very nice. It is useful to you. Okay, you purchase the course. If you like, really like, you purchase the course. Otherwise, you have to listen in YouTube also. Freely available is there in YouTube, but not entire the portion. Some important topics only we have to upload in YouTube. If you really want to interest to get the subject thoroughly, you have to join in app. Clear? So thank you once again. You are patiently listening. We will meet with another video. Please share and subscribe to your friends my YouTube channel.